once again to talk about embedded software. Today I want to think about libraries, specifically object code libraries. What are they about, what are they for, why do we use them, that kind of thing. Now, start off with thinking about how we develop embedded software. Well, we write a number of modules of code in C or assembly language or whatever language you choose. We compile those, we assemble the resulting output, and then we link it all together. That's all pretty straightforward. However, we'll probably want to be reusing some other code. So what you can do is link a library in with the rest of your code, and then what the linker does is resolve any references that it can't find in your code by looking in the library. So if you call a particular function, it's not anywhere in the modules you've presented, and you can find it in the library, all is well. So what is the point of this? Why don't you just link in these other modules? Well, it's much simpler to create a library of reusable code containing lots of different functions, lots of things you might need, and then have the linker extract exactly what it needs when it needs it, and not link in the entire contents of the library. Because after all, with embedded systems we always have some limitation on resources. The memory may not be tiny, but it won't be colossal either, and we can't afford to waste it. So such a library might be one that you created. It might be containing lots of functions that you can use in multiple projects, and that's a very efficient way of distributing them. Or it might be one provided by your development tool vendor. Now, normally development tools do have a standard library with them that would contain two things. It would contain implicit and explicit functions. Now, implicit functions are ones which are calls to which are generated by the compiler to perform a sequence of actions which is frequently required. That's completely transparent to you as the programmer. Explicit functions are ones where you've called them in the knowledge that they are in the standard C library. Functions like printf and so forth are the obvious examples, but there's a lot of them. Take a look at the C standard, you'll see there's a fair old list of standard functions. Those are all in the libraries that your tools vendor will provide. Another use of libraries related to this really is with real-time operating systems. Now, real-time operating systems, once upon a time, were just a chunk of code which you linked with your application and it contained all the functionality you needed. But as the capabilities of RTOSes became greater, the overhead of including everything in every application became apparent and something needed to be done. So scalability was invented. Scalability is actually a very simple concept. Each of the each of the services of the operating system are functions in a library. So when you build your application, you call the APIs, the service functions of the RTOS as you need them, and just the code for those are extracted from the library. Now, there's an interesting trade-off here, because if you only extract the specific functions that you've called, then linking will take a bit longer, but the resulting image will be optimal because it'll only contain the code you need. So that's what's called fine-grained scalability. Some RTOSes use a different approach, whereby if you call one particular library function, one particular RTOS capability, you'll get the whole group of related ones. This means that linking will occur a bit faster, but you will have some overhead code that you don't really need. That's called coarse-grained scalability. You can probably guess which I will prefer. And you don't generally have a particular choice between the two. It depends on how the library was built. So that's a brief introduction to what object code libraries are all about. So next time you link one, make sure that you put it in the right place in the linker command file, because you want the library looked in last of all to resolve any calls you've made. And don't forget, you can include multiple libraries, and typically the linker will go through them in order until it resolves any symbols that it can't find. So that's it for today. I'll be back again soon talking about embedded systems, and I'll see you then. So, bye for now.